So here is a former exam question, and we'll just read over it and see if it sounds familiar. Sketch the shear V of x and bending moment M of x diagrams for this hanging beam on the labeled lines below. Okay, first of all, I took this off of the solution to this exam. I don't have the original. So down below there was stuff for doing the plotting. Then it says label the sketches to show the point in the beam where the bending moment is maximized. Well, we've seen that before. Also give the maximum bending moment at this point. Same question we're always getting. This comment about penalty, that wasn't actually, this was a note for the grader that if they did not use the coordinate system that I provided, they took 10 points off. So if I give you a coordinate system on an exam, use it. Okay, that's the bottom line from that. So what I want to get across when you look at this problem is it's the same as all the others we've done, just a different beam. So what does this problem have in it? All right, we have a point force of 100 newtons, so there's nothing for 2 meters. Then there's nothing here for 2 meters, and this beam is hanging. Instead of sitting on a floor, it's hanging from a ceiling. All right, so that says that the support force is pulling it up. But that's actually the same as the support on the floor holding it up. It's no different. Don't let the ceiling bother you. Then we have a distributed load for 6 meters at 50 newtons per meter. Then 4 meters of nothing. Then another support going up. Then 4 meters of nothing. And then a 200 Newton meter pinch the bottom torque load in the end. That's it. So let's knock this problem off. All right. So conceptually, what would you do? Here's the free body diagram. Nothing, 2 meters. The support, 3 meters. So we had a 6 meter uniform load, so we'd go over 3 meters, and that was, just look at this again really quick. That was 6 meters of 50, so that's 300. So we go over 3 and put that in, and you'll notice that's what I did. Then you'd have 3 plus 4, 7 to get to FB, the support. So I'm calling this A and that B, really creative names. Then we have 4 more meters, and we come up to this moment. So that's what we have there. All right, so if you sum forces or some moments at A, which would be my usual way of doing things, you have, this is going around clockwise, counterclockwise, so you have 200 times 2, moments being taken at A, so that does nothing, minus 300 times 3 plus FB times 10. And then this is clockwise, so minus 200. All done. Solve for FB, come up with 90 newtons. Summing forces in the Y. We have 100 down and 300 down, that's 400. This is 90, that leaves 310 for A. Or you can do a full equation here if you so like. I'll leave that to you. The left end, right there, there's no forces, no moments. So the initial shear and the initial bending moment are both 0. Put in very big zeros right here. Done. Okay. The right end. So if we go look at the right end, there's a moment. There is no force, therefore the shear is 0. And then this is pinching the bottom, therefore this must pinch the bottom to counteract that. So I drew that in positive. It needs to be a negative 200. All right. So at the end, there's minus 200 at the end. And we'll just go in here and bam. And there's the end point for that and the shear. They are in. This is our usual way of solving these problems. Okay, so now we need to go through and walk the beam. So as you walk across, what did we have? We'll just bring this in for a moment. So if we look here, there's nothing for 2 meters, then we drop 100, then we have nothing for 2 meters. So let's make that happen. So there's going along at 0, and we do that. Then there's nothing for 2 meters. So here we are at 2, coming up to 4. So this is A. And at A, we determined that was 310. So if we're at minus 100, we add 310. So let's see. That's about 300. We'll go just a little bit above. And note, we're at 210. Make it bigger so you can see it. All right. So went across, dropped 100, did nothing. Went up 310. Now we're going to drop 300. All right. So we're at 210 to drop 300. We're going to do that over 6 meters. So counting out 6. 1, 2, 3, 4, 5, 6. That's right here. All right. So if here's 100, 210 minus 300 would take us to minus 90. And that looks to be about minus 90. That's close enough. So bam, we drop it off. Okay. I need to find out where this crosses. So let's go over here. And we have 210 minus the slope of that is this number, 50, minus 50. This is at starting at 4, so we'll just put in an x minus 4. Set that equal to 0. And if you solve for that, you will come up with x equals 8.2. And here we are at 10 at this point. All right. So we've gone across 6 meters. Now we have 4 meters of nothing, and then up 90 for that support. So 1, 2, 3, 4, 1, 2, 3, 4 right here. And we go straight across. Now we're going to go up. And we have zeros all the way across. So there we have that. Okay, now we have to do the bending moment. All right, so we have 2 meters of nothing, or yeah, we're in meters, so 2 meters of nothing. So we'll just go down and note where that is. And I'll fill in the line rather dramatically. Okay, now I have 2 meters down 100, so I'm going to drop 200. So it's 4. Over. And there we are. Let's see, I have trouble getting all that in, so we'll adjust the depth of field here. There. All right. So now we have this piece. So here's 8.2. Let's just follow that. We're going to have action at 10. We're going to have action at, there's 8.2. There's 10. So I'm just following up lines that I can work with. All right. And I will note that this was not the most straight of lines that I drew, but Again, these are just sketches in an exam, so we can't be that picky. All right. So I need the area here. I'll call this one A1, this one A2. A1 is 210 high. It goes over 4.2. Divide by 2. We come up with 441. Okay. So we're at minus 200. We had 441. That'll take us to 241, which, yeah, somewhere around in here. Something like that. All right. A2 is going to drop to minus 90. So this is negative area. 8.2 to 10 is 1.8. Divide by 2. That gives us 81. All right. So this was at 241. If we take off 81, we will drop to 160, which, yeah, it's probably around there. So we'll just, yep, come out so good. Close enough. All right. So we dropped to 160. And now we have 100. This would drop, let's see how, this was at minus 90. So here we are, minus 90. And then this went over 4 units, so that's 14. And let's see, total length, reminding myself, 10 for 18. Here we are, 18. Okay. So now I'm coming here and I'm going to go over, let's see, 94, 360. So this is 160. And let's line this up. It's right around here. So that says drop at the same slope, straight. Yeah, that worked out pretty good. Takes us to minus 200. Then we just follow over to minus 200, and we are good. We have walked the beam in force and in moment. And then the question says find the maximum bending moment. So somewhere here you would simply say max MB equals 241 Newton meters at x equal 8.2 meters. Done. And this one's in the can. One more problem to do. I'll see you shortly.